Hello, let's learn about spanning tree. And in this diagram, I just prepared a three switch simple diagram in order to go through the process of our spanning tree to elect who's supposed to be the routes, which part's supposed to be forwarding the traffic, which part's supposed to block the traffic, right? And the idea of spanning tree is to prevent layer 2 loop in the environment. So in this example, you notice that let's talk about from S1. I can forward my traffic to S3 either through directions. I also can forward my traffic through directions, right? So if we don't have a good control, what happens is my traffics can be something like this, right? They can flow in my environments in the indefinite loops behavior. And when the loops happens, what happens is it's going to eat up all my CPU resources, and up it might bring down my networks. And this is something that we try to prevent with the spanning tree protocol. Now, the first thing, spanning tree will try to elect who's supposed to be your root bridge, right? So by default, they are going to try to compare the priority. So by default, the switch is going to have a priority of 32768. So if I don't change them, meaning that everyone will have an equal priority. So if the priority is equal, I cannot use this value in order to decide who's supposed to be my root bridge, right? So if you wish to manually force one of the switch to become your root bridge, you can either assign the priority. Usually it's going to be the lowest priority 0, then it's going to be increments of 4096. Next one will be 4096, 8192, and on and on and on, right? So really depends on which priority you want to set on your switch. Now let's assume that we use default value on the switch. This is where they are going to fall into second conditions, where they will try to compare the MAC address. And the good things over here is spanning tree like to compare the lowest MAC address, right? So we are going to compare the MAC address between this S1, S2, and S3, AA11, BB22, 1133. So once you compare, so the lowest value is going to be on your S3. This is where I get my roots. So I just label this guy as my root bridge right now. Now the next thing, they are going to assign the row for the ports that exist on your roots. So some of the port row that we are going to see later on is going to be designated ports, root ports, and also I'm going to label the other one as a blocking ports. Okay, some of the protocol like RSTP, they might call it as an alternate ports, but I just refer it as a blocking ports for easy understanding, right? Now, for your root, this is where the port must be in the forwarding states all the times. So they are going to elect as a root bridge, then the port row will be designated on both of them. Now, we are done. By define who is going to be our root bridge, usually they are going to exchange what we call as BPDU message between the switch in order to go through these elections. Now, we have another two switch, which is your S1 and S2. We call this as non-root bridge, right? So what happened is we need to figure out what is the fastest way for my non-root bridge, which is S1 and S2, to reach to the roots, right? So how do we calculate this? Basically, it's going to be according to the link speed that we are using over here. So in my example, I take example on the gigabit interface, meaning that all the ports having the equal speed over here. Spanning tree already predefined the cost that is going to assign to each individual speed that we are using in the spanning tree. So really depends on the flavor of the spanning tree. If you're using the traditional one, this is your cost value. Again, spanning tree like to take the lower value, lower equal to better priority. Same goes to if I'm going for RSTP, this is going to be the value that we use in the calculations to find out the best path to reach to your root bridge. Now in my example, let's take I use STP as a calculations, for example. Now right now, if I'm using gigabit link, meaning that all of them is going to be the cost of 4, right? So cost of 4, this link, cost of 4, this link also going to be cost of 4, right? Now, from my S1 point of view, in order for me to reach to the root bridge, I have two directions. I can either use these directions. I also can use these directions, right? So when we go through the calculations, if I use directions from S1 directly to S3, my cost value is only 4. But if I use my direction from S1 going through S2 then S3, my cost is going to be 4 plus another 4, right? So meaning that over here it's going to be 8. So if you compare 8 and 4, definitely 4 is going to be better. According to the spanning tree, they like to take the lower value. This is where this path is going to be my preferred path in order to reach to the root bridge. And this is where I get my root pods. Okay, so I'm going to label as root R, right? So this is my root pods. There's going to be fastest link for me to reach to the root bridge. So we already complete one segment. Done, right? Now I'm going to do similar thing on my S2. Again, we go to similar comparisons. Okay, if I use this path, what is my cost? Only 4. If I use this path, right, my cost is going to be 4 plus 4 equal to 8. Again, 4 is going to be better. So we get a root pods on my S2 as well. So let's put the row of this pod. This is going to be my root pods. We are done, right? So we done this segments, we done this segment. Now we know that this is the last segment. So definitely the last segment, they are going to have one of the link block over here to prevent layer 2 loops in our switching environments. Now the next thing they need to figure out, on each of the segments, we need to have at least one designated pods. So in this segment, we need to figure out which one's supposed to be our designated pods, and the last pod is going to be the blocking pod later on. Now, how do we determine this? Again, we are going to compare the priority, and because of priority is equal, right, we are going to take our MAC address as a comparison between S1 and S2. So when I compare my address, AA11 and BB22, looks like AA11 is lower my address, meaning that it's going to be better. So when he is better, against my spanning tree will elect him to become designated pods, right? And automatically I know, because this is the last pod that I have in my spanning tree, so this is supposed to be my blocking pods. And the end result that we get over here is the traffic will be blocked by spanning tree on this segment. All your traffic is going to flow through your root bridge after the spanning tree convergence already complete the operations. So this is the example of the spanning tree protocol. Thank you.